Hello and welcome to this TIMSS data analysis training video. In this video, we'll learn how to use the IDB analyzer for statistical analysis. In this video, you will learn how to use the IDB analyzer to conduct analysis with the student, school, and teacher data, calculate percentages and means and significance testing between groups, calculate percent of students using benchmarks of achievements, and you will learn how to calculate regression coefficients with several variables. Information about downloading and installing the IDB analyzer is presented in a separate video. The first thing that we need to do is define the scope of work. In a separate video, we selected the countries of interest, this being Ireland, Japan, Lithuania, Singapore, and the United States. And we created files with student data combined with school background characteristics and mathematics teachers' background characteristics. Now, before we continue, I want to remind you of the two most important rules in data analysis. Number one being to check the data, and rule number two being to never forget rule number one. And it is kind of funny, but one of the things that I will do throughout the presentation is show you where you can check the data to make sure that the results are trustworthy. We're going to have three example sets. In the first one, we're going to look at what is the average mathematics and science achievement by number of books in the home and school location. And we're going to look at the average liking learning math lessons by gender. So let's see how we go about calculating that. We're going to do first open the IDB analyzer. And then we're going to work with SPSS in this case. But note that the operation of the IDB analyzer is exactly the same with when you're using SAS if that is your software of choice. We're going to select analysis module in this case. And what you'll see here is that it has already identified the file that we want to work with. And this is because this is the file that we created last with the merge module of the IDB analyzer. So we selected the file. Analysis type, we're going to do using student weights. Notice that if I use math teacher weights, it's not going to let me. Science, it's not going to let me. So it won't let me do unless I use student weights. And this is a file where I merge student with school data. Student weights. We're going to compute in this case percentages and means. And we said that we're going to look at, we're going to click here in possible values, math and science. I'm double clicking here so we move the variable to the right. And we want to look at these variables by school location and by number of books in the home. So there's two ways to do that. I'm going to go, so if I put it as a grouping variable, it will do books in the home within school location, or the other way around, school location within books in the home. So instead, what I want to do is I want to generate a table of math and science by books in the home. And I'm going to click here, look for the variable books. And this is variable here, general amount of books in your home. I'm going to copy it here. And this one on school location, general immediate area of the school, move to the right. Another thing that you could do in the SPSS side is if you right click on the variable, it will tell you the category. So we have 5 books in the home categories. And for location of the school, we have right click, also 5. So we're going to be calculating percentages and means of the possible values, math and science, by school location and by books in the home. So I'm going to go down here, define, and I want to save this in the work directory. And I'm going to give it this a name: math, science by books, and location. Okay, so you can do one variable at a time, and it might be easier, but I just want to show you that you can do several variables simultaneously, so that you can set it up at once and then run it, generate just one syntax that will do all these analysis. Notice that the total weight is automatically selected. This is the sampling weight. And if we do start SPSS, it will create a syntax that will look like this. And here you have, see, this is the file that's going to be reading. These are the variables in the analysis, how many replications, the jackknife sum variables, etc., etc. So, and here's going to be saving the output. So there's two ways to execute this. One is to run all, or you can do also Control A. I'm going to now Control A, then Control R, and I'm going to run it. I'm going to pause the video, and then I'm going to come back when the analysis is done. Before I pause, you will see down here that it will tell you that the progress is happening. Okay, so let's see what we have here. We have the first thing that we're going to see is we're going to see unweighted statistics for each of the countries by the books in the home and for each one of the plausible values, and we have the number of cases, minimum, maximum, mean, standard deviation. And this is again is to check the data to make sure that we're reading the data correctly. You want to see means that are reasonable here, minimum that are reasonable, maximums that are reasonable. You have that for each country: Lithuania, Singapore, United States. And then you have now weighted statistics. And then you have the same statistics, but now weighted. And we're going to keep scrolling down. And then you're going to get to the section where you have the plausible values that has processed, math, 150 replicates. This is because we're using the 150 replicates jackknife 2. 5 plausible values. They get summarized when we compute the variance. And we get a table that shows for each country, each category, the summary statistics. And we have number of cases, some of the weights, percent of people in each category, standard error of the percent, the average math achievement, standard error of the math achievement, standard deviation, and percent missing, and the number of variance strata. And this is the number of variance strata that contribute to the this estimate for this group. So in other words, in how many variance strata the cases for Ireland that have none or very few books are spread. And we keep scrolling down, then we see a graphic that shows the relationship between number of books in the home and math achievement. And we see that those that have more books in the home tend to do higher in math than those that have few books in the home. So there seems to be a relationship between math achievement and number of books in the home across all the countries. Next, we have a bar chart displaying the same relationship. And we have the percent of people in each one of the groups. And we see that, for example, Singapore and United States is the one with the students, with more students in the fewest books in the home category. That's what we see here. So this tells us the percent of people at each one of these categories. Then we're going to see the same results, but now for science, because we requested it for math and for science. And we see the same, pretty much the same statistics unweighted. Then you have them weighted. And then you have that it worked with the 5+0 values, 150 replicates, the table with the results, and the relationship between science achievement and number of books in the home. So again, more books in the home, higher achievement. That's the relationship here. Scroll down, and then we're going to get to this variable. Now we see this is for the location of the school, and we see the same statistics, unweighted statistics. And I'm going to skip to the graphic because it's going to be the most useful thing to look at in this case. And we see that the relationship between school location and math, there doesn't seem to be a clear relationship here, except in Lithuania, maybe those that are in remote rural areas are doing pretty poorly relative to the rest. But in this case, if we go to, let's see, Lithuania, rural, there's only 21 cases, so it's very few cases. So, it would be, you would have to take that into account when you interpret. So this is probably one school in rural Lithuania that did relatively poorly. Same results, Singapore, they're all in a urban densely populated area. And you see the results for science with school location. And you should see the same pattern. Lithuania, all others, there doesn't seem to be a relationship between science achievement and school location. So that's what comes out in SPSS. Now, if we go back to our work directory, we'll see that we have a new set of files here. We have the math science by books and location, that's the syntax in SPSS. And then we're going to have the SPV file, and this is the SPSS output file. If you had chosen SAS, you would have a SAS file, a list file, and a log file here. And you would also have math science by book by location, and I'm going to open this one in Excel. And you'll see that we have there for each country, for each math, science, and we have BSBG04 because it's books by books and location, but it's using BSBG04 here, the books in the home. And you would have the variable, the values, and the statistics that were reported in the table. The sign effect and some log information. What I would suggest, rather than go through this in the video, is that you go to the manual and it will explain what each one of these columns contains. But of highlight here is number of cases, some of the weights, percent of people by group, mean on the variable of interest, standard error, and the sampling and imputation variance, in case you're interested in looking at that. So that's the main results table. You would also have these SIG files, and I'm going to open one of them for science by books in the home. And in this file, you will have, for each country, you'll have the comparison between the reference group and the comparison group. So this is a comparison between those that have no books in the home and the other categories. you have the mean plus all value, you would have the mean plus all value for the comparison group, and you would have here the difference, and this is the t value, and then you have here the difference, which will be actually this value minus that value, and then you have the standard error of the difference, and you have the difference, the t value of the difference. So this value here will be equal to the difference divided by the standard error of the difference. So if we do this equals to this divided by, let's do this correctly, it's going to be, going to delete this is going to be equal to this divided by that. It should give me 8.73, which is the value that we have right here. Okay. So it tells us that there is a significant difference between those that have no books and those that have more books in the home when it comes to, in this case, science achievement. So you will find one of these for each comparison, and you also find, so you have the results in Excel, and you have an SAB file that has the results in an SPSS dataset. Okay, so let's do the other example analysis that we're going to do. So we're going to go to the IDB analyzer, and now I want to work with the average on liking math. So I'm not going to use plus all values. And there's a variable here, so I'm going to do the analysis by gender. I'm going to use this variable by gender. And we're going to do, our analysis variable here is going to be liking learning mathematics, the scale. So we're going to look at the average scale score for students liking learning math lessons by gender within country. So define like math by gender. And I'm going to start SPSS. And we're going to run all. And this should run quicker than before because we specified one analysis and we're not using plus all values in this case. So we already have the results. And let's go back to see. So let's go back to the folder where we were a few minutes ago, and we'll see that we have the files here for liking math, significance testing of liking math by gender, and we had the results by gender, the syntax file, and we're going to get this results here, and we're going to have descriptive statistics unweighted to check on the data, descriptive statistics weighted, a little table with the results, and we have this graphic here that shows how it seems that boys report liking math more than girls in most countries except in Lithuania. I think this is this one, and then Ireland also. It seems relatively flat, that line. If we want to see if these results are statistically significantly different from between girls and boys, then we would go and take a look at the significance output here, and we would see whether that is the case or not. So let's do that. And we will look at this mean x difference t value we see that this is Ireland, no significant differences. Japan, very different, no differences in Lithuania. Very different in Singapore, very different in the US in terms of liking math. And the difference is that boys like math, report liking math better than girls. So this ends our first set example. We're gonna do the second one now. You might want to take a break, but this video will continue. Okay, so in the second set of examples, we're going to look at the proportion of students in each of the science proficiency benchmarks and whether there is a relationship between liking learning science lessons and achievement. So we go back to the IDB analyzer. We have the file. We have student weights. Now we're going to look at select benchmarks here. And we're going to be using plus all values, so there's no option here. There's three ways in which you can compute benchmarks. One is discrete, which is going to give you just the straight percentages. Cumulative, which is going to give you the proportion of people at or above these benchmarks. Benchmarks are points in the distribution that have a particular meaning. And discrete with analysis variables, and this is what we want because we want to look at the relationship between liking science lessons and science achievement. So we're going to select this one, and then we're going to select our analysis variable here is going to be like learning science, the scale, plus all values. We're going to select science plus all values, and from benchmarks of achievement we're going to select the ones that correspond to TIMSS, 400, 475, 500, and 625. There's an option here which will tell you the percent. So this is, as it is going to tell you the percent at each one of the benchmarks by country. And this is going to, if you select this option, it's going to tell you the percent within each benchmark that belongs to each one of the countries. So again, I will refer you to the manual for an explanation of exactly what that does. So we're going to define here, it's going to be like science by science benchmarks. Start as PSS, and you'll see the code here, and we're going to do run all. So once this is done, this is what you get, and we're going to go to the top, and we'll see again, like before, unweighted statistics for each one of the variables, the plus all values and the student liking learning science by country. Notice how in Lithuania there's a 0, and I'll talk about that later, what that means. Weighted results. Working with the 5 plus all values. And the table. So we have below 400, from 400 to 475, the number of people in each group, the sum of the weights, percent of people, and the average on this liking science. Now, Lithuania doesn't have it. Remember from one of the first videos that you saw in this series that some countries used an integrated science background questionnaires and others did a separate science background questionnaire. So we selected the variable for the integrated sciences, and in Lithuania they used the separate sciences background questionnaire, and therefore there isn't a value for this variable here. Get the numbers, you get also then similar story. Those that do better are those that tend to like science more across all the board, across all countries. You have the same results in a bar chart. And you have the percent of people at each one of the proficiency levels. And here you see that Singapore has the most students at the at or above 625. Like the other ones, and I showed you earlier, you get the results in Excel. So you can open the files, and then you'll have the significance testing, the corresponding significance testing between the subgroups, and the percentages and proportions of liking math by gender. Okay, so in our last example, we're going to look at the relationship between the number of books in the home, school location, and whether the teacher studied mathematics teaching and math achievements, how that affects math achievements. So notice that we're going to use a relationship, and here we're going to look at specifically linear regression and between number of books in the home, school location, and teacher studying math. So we're going to go to the IDB analyzer, and now we're going to be selecting the file with teacher data that we selected, which is this one, subset 5 countries, student and math teachers. Open. For analysis type, notice that if we select students, it's going to say no, because now we're using the teacher data. So we have to use math teacher weights. For statistics type, linear regression. When you're using plausible values, listwise or pairwise or mean substitution, this is so basically pairwise, when it does regression or also with correlations, it will build a variance covariance matrix with only in listwise with only the cases that have complete data, and in the pairwise it will build the matrix with any possible pair. So there are different ways of dealing with the missing data. I would suggest that you look at the SAS or the SPSS manual if you're unclear as to how these work. So going back to the example, we're gonna be predicting our dependent variable is gonna be a plausible value, and it's gonna be math achievement. And we're gonna be predicting that from the following categorical variables. We're gonna have books in the home. Books in the home has 5 categories, and we know that because if we click here, details, 1, 2, 3, 4, 5 categories. We have school location, and this one again, right click, details, 5 categories. So we're gonna change here this to 5, this to 5. And the other one is whether the studied, let's see if we find it here, general major area of study was mathematics. Right click, 2 categories. The manual will tell you more information about what these mean, but there's basically 5 categories, 2 categories. You're going to use once as a reference category, and what the program will do is it will dummy code these variables and enter them into the regression, and that's how you would interpret these coefficients. In this case, we have no continuous variables as predictors or as independent variables, but you could add them, and we have no plausible values either. Using the math weight, dependent variable math achievement, and then we're going to define the output file, and we're going to call this predict regression math from location study math and books at home. Save. and we're gonna start SPSS, and we get this here. We get the syntax here. So what I'm gonna do, I'm gonna run this, and when it's done, I'm gonna come back. This will take a while. If you're doing it on your own, this will take a while, but I'm gonna run it, come back, and we'll go over the output. Okay, so we're done, and I'm gonna go all the way to the top again to review the output. It's gonna show you these are the categorical variables that are being used in the regression. And it does it like this because the categorical variables do not have to be contiguous, so it does something called auto recode. So you get one first category, second category, third category, and so on. Here we have descriptive statistics for each one of the variables, and then we have dummy coded the variables. The manual explains how the dummy coding works in the appendix. There's a section in the appendix that explains how this works. But basically, the number of books in the home variable, since it's categorical, it gets dummy coded using category 1 as the reference. The variable for location gets also dummy coded. And the variable for whether the major area study was mathematics. So keep this in mind. Here's 1 is a no, so those that said no get a 1 here. So this will be important when interpreting the results. Here we have descriptive statistics for each one of the variables. Here we have them weighted, descriptive statistics. Processing log. Here we have the number of variance strata contributing to each one of the groups, here in this case countries. And here we have the first report. So here we have the R squared, 0.21, 0.1, 0.2, and so on, with the corresponding error. The adjusted R squared with the corresponding error. So if you wanted to know whether that R squared was significant, you would divide this by that, and that will give you the t value. Here we have the regression coefficients. And, here we have the descriptive statistics for each one of the variables in the equation. And here we have the regression coefficients. So we have the constant, and we see here basically the more books in the home. This is what's going to tell us: the more books in the home, the more achievement that you have, or it's related with higher achievement. The location doesn't quite, and here we have the t values here, right? So we have for the books in the home, they are significantly different. For location, there's no statistically significant differences, and that's what that shows here. And we had seen that before when we did the mean tables using the percentages and means procedure. And then this is the variable on the major field of study, and we see that the coefficient is negative, meaning those that say yes, which have a 0, actually do better. So careful interpreting these regression coefficients, because this will mean since the no's have a 1 and the yes have a 0, then the no's have a lower value than the zeros, meaning those that say no, their students don't do as well in mathematics. And we have that for each country. Table average. And you see that it's very similar across all the countries significant in the US. Okay, then if you go to the work directory, for TIMSS 2019, you'll see that I'm going to do this sort by modified. So you'll see that there is a series of files here from the regression of math from location, study, math, and books in the home. So you have the different outputs. And again, the manual explains the contents of each one of these outputs, but here you have the regression coefficients. Here you're going to have the descriptive statistics. And here you're going to have the model statistics such as the R squared and the adjusted R squared. To summarize what we did in this video, we used the IDB analyzer to generate several report tables at once with using means and percentages, benchmarks, and regression. We conducted significance testing and generated several related graphs. And we worked with the school and the teacher level variables simultaneously. Remember that in the case of TIMSS, reporting is always done at the student level, as in percent of students attending schools of one type or another, or percent of students taught by teachers of one type or another. So this is something to keep in mind when you are interpreting your results. Thank you. We hope you enjoyed this video and learned something new. For questions about the contents of this video, please ask us by email by writing to egonzalez@ets.org or falk.brace@iahamburg.de, or ask us during our next online session.
This video was created for the academies held by the IEA ETS Research Institute. Any commercial use of this video is prohibited unless explicitly authorized in writing by the Institute or its funders. Funding for the Institute comes from the International Association for the Evaluation of Educational Achievement and the Educational Testing Service.